right, so we're at limits and continuity. Yeah? Let's talk about what continuity means. So we have the function that's continuous in some x value, right? You kind of got the idea that you never pick your pencil up when you draw the function, right? That's the basic idea. We're going to get a little more detailed, obviously. What are some of the discontinuities, and what do they look like? Okay. Point discontinuity. What if I did this? Still discontinuous? Yeah, still a point discontinuity. Okay. I'll let you catch up.
Yeah, hilarious. I get my head on the table.
What's that called? Jump?
I don't remember that. I don't really know.
And what's the last one? Yeah. We have three types of discontinuity: jump, point, and infinite. This is where you kind of have to separate limits versus continuity. Okay. This is not continuous, but the limit exists, right? Not continuous, the limits exist? No. And both no, right? Okay. What is the limit as x approaches this c value from the left? That y value, correct? This function is left continuous. Because that is solid. So for continuity, the point has to exist. This function is not right continuous. Because this hole is open.
What is that like open hole mean?
It means that that does not exist. It can get really, 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 really close, but it never gets to that location. Is this left or right continuous? Neither. Now this one. Oh, yeah, so it's continuous in both left and right. How about that?
Left, right. No. What? I don't want to go crazy with my kids.
I'm just trying not to.
Daddy.
Sorry. These are not. They are touch C. No, they are not left or right continuous. You have to touch that point. You have to get to it to have continuity. It has to exist. Okay, these do not exist at that point. So they're not left or right continuous. All right. All right. So that's kind of a graphical, conceptual idea. Let's talk about the real definition. Where if this is a free response on an AP level test, chapter 2 test, this is what's going to happen. Okay, this is what you got to do. You have to think of everything. I'm going to make sure that works. So f of x is defined on some open interval.
Is that A and B or is that little tricky?
These are a and b. Could be from some x to some x values, an interval. f of x is defined on an interval ab. With a less than c. Okay, so c is just in the interval, right? F is continuous at x equals c. It's a three-stepper. I'm writing it differently than your book. This is easy. F of C exists. It's got the solid dot, right? Okay with that? All right. The limit is why we're in limits. As x approaches C of f of x exists. You will have to show the limit as x approaches C from the left equals the limit as x approaches C from the right. So you have two limits to show. This is, you have to show this here in order for that to happen. Right? They have to match. Remember that? Left and right and come together. So that's 1, 2. Okay, third. This is the easy part. The limit as x approaches C, f of x equals those two are equal. 2,
equals 1. That's the easy part. If they match, you're good to go. You just say because this equals this, f is continuous at c. Okay.
So if f of c is this, then we automatically know 3 is this?
No. This has to exist, this has to exist, and they have to be the same number. I'll show you the example.
But 2 and 1.
Not necessarily. I'll show you an example where they're not the same. So, well, let's show you here. Okay, f of c exists here, right? Call it at c. Right here. There's a solid dot, so f of c exists. Right. What's the limit from the left? Y. Let's call this y2 and y1. What's the limit from the right? Does the limit exist? No. Therefore, not continuous. By violating condition. Okay. This one. Let's say that's 3 and that's 2. What's f of c? 3. What is the limit? 2. Do they match? No, not continuous. Right? Does that make sense now? Okay, really formal definition. I expose you to this because you're going to need it. How do we use it? Let's look at a function. Let's start with a really difficult. Let's start easy. So prove. Give me a polynomial. That's all I hear. It's easy. It's a plug and chug with it. So we're going to prove that x cubed is continuous to x equals 2 using the definition. Every time you do one of these, use the definition because you have to have it memorized. Okay, what is f of 2? 8. That's step 1. Make 2, plug it in. Now what is the limit? X approaches 2 of f(x). Okay, that's a plug and chug. The limit, this is where it usually gets harder. Okay, where you have to do a somewhat difficult limit. Since you need to actually write this out, f of 2 equals the limit as x approaches 2 of f of x. F is continuous at done. Yeah. This is a step by step. Okay. Done it. Okay, so let's see, let's try harder one. Like that. Prove. This word might come in there sometimes. Piecewise function. Yep, I know, you love this. to prove that function is continuous at x equals 3, discontinuous at x equals 1. I'll show you the graph afterwards. We're just going to do this one completely algebraic. So which one do you want to do first? Continuous or not? Okay, so on here. First step, f of 3 is yeah. So if your x value is 3, it equals that value. The limit of x approaches 3 of f of x. Now this is where we need to do the left limit. Which one of these are we going to use for the left limit? That one? Or that one? That one. Because we're approaching 3 from the left. So smaller than 3, we know the answer is 3. The limit of x approaches 3 from the right. That's this function, right? Yeah. It's bigger than 3, so we're coming in on this one. The answer is x. It's x, so plug and chug, we get 3. Look at that. That's a big F. So we know that limit exists. And we would make the same statement again. Since these two are equal, it's continuous. Let's see. Okay, I'm writing little f's and I should be writing big f's. Yeah, big F.
Does it really matter?
It does matter. Because if you do this on the exam, you will not get credit.
But if you like made it little.
So if you make a little F, they're going to change them. You get it all right. You just put a little F.
That's so stupid.
It's not stupid because little f is not in this problem. They don't know what you're talking about.
Okay, but what if it was a
Half
little
F
F?
throughout. Yeah. It's a big F. Okay? Got it? No arguing with this one. This is the way it is. Okay.
So if I wrote a little F up there, would I make all of those little F's?
If you did this,
Yeah.
then it would be little f.
I did
You
that.
don't do that. Okay?
I copied it.
Now, if it's defined as big F in the problem, you need to use big F. If there's a reason I exposed you to that, and I didn't. Use the bigger, better. Okay? It's very, very easy to use smaller case letters. F is continuous. Okay, why is F not continuous at 1?
That's what I'm
What's F of 1? Okay. What's the limit? X approaches 1
That
to
big
the
F a
left.
little
It's got to be.
yeah,
left limit? Using that one, right? One. What's the limit to the right? Bummer. The limit doesn't exist. So if we're coming in from the right, so from above 1, we use this function. That value is 3.
Why can't it be 1 and it be bigger?
This, we're working with 1. The x value is 1. So the graph, so this is why it's not continuous, right? The limit doesn't exist. The graph of this function looks like this. This is 1. Okay, jump this counter. So you see the limit from the left is 1, the limit from the right is 3. They don't match. So since the limit does not exist, since I would say, since, let's not get lazy, the limit of x equals 1 of f of x does not exist, f is not continuous at x. This is what I would write as my answer. You could write that. Yeah. Oh, will it work? I think this is the better option, but it will work. They are not equally saying two facts. I think there's one problem on the homework that you're going to look at. You're going to have to think it through. But I think you have in your brains. Again, we're going to talk about it Tuesday. So let me give you the word, and I'll let you work on it for the remainder of class. Okay, so we have prelims 2 and 3, and then the exercises 2 through 4, 17, 18, 25, 27, 49, 57. Some of these are really easy, left and right continuous. You just look at a graph. 84. And then I'll take off the chapter 1 spiraling, but 2.2 gets you some practice there. 2.3, 24. Again, give me a report about how long you guys are spending on this stuff. Okay. I don't want it to be too much. So I've been taking a little bit out for you, but if it's still too much, I don't want you spending like 30 to 60 minutes is good enough. If it's over that, we need to change it. Okay? You don't need more than an hour for your sanity and for practice. Huh? Okay?
Homework, but I just don't understand it. Like I don't even know where to start. I spent like 20 minutes like researching it, looking for my book, and like doing it.